Is it a bird?
Is that plane?
No, it's 1000 Hour Aviation.
I'm Jacob,
And I'm Tyler.
and welcome back to our third video.
Today we're going to be discussing our actual ideas for what we're going to make our plane to be for our EPQ. So as you can see, we have designs up here, such as a pure helicopter, a compound arc, a tilt rotor, a tilt wing, a folding tilt rotor, and a lift fan, which we got from this website, wherever it is, JSTOR. It's right here, and we can see some like facts about the altitude and the airspeed in KTAS. And how fast is the KTAS, Jacob?
A true airspeed in knots is approximately 1.1507 miles per hour. Although I want to fact check that because that is incredibly slow.
Yeah, that does seem very slow. But when you think about it, if it's going like 500 KTAS, then I mean that could be a thing. It does seem quite reasonable. You know.
Wait, give me a minute. I want to actually find out what. So, 1 knot or one knot true airspeed is equivalent to 1.852 kilometers per hour. So, if we take the number of knots we have and multiply it by the kilometers per hour, then we get multiplied by 1.852, we get our speed in kilometers per hour.
Okay. But the thing is, uh, see, we're trying to make like a scale model, like radio controlled plane or VTOL, and all of these designs, even the helicopter here on this graph, they start at a true airspeed of nearly 200 knots, which is like about 300 kilometers per hour, probably. We're not going that fast. We're not gonna be going that fast. So we have some examples of what the different. Where is it? This. So this is a. It's like a tilt. It's a tilt rotor, and kind of a lift fan in one. Because you've got the tilt rotors on either end, here and here, and then you've got the lift fan in the middle, where these can tilt on pivots to so they can lift it up like this, and they can tilt it forwards to make the plane go fast forwards. And then we got this one. It's a tilt wing, where there's a lot of propellers. There's about 10 here. So it goes in this configuration to go up. And then when it gets up, it'll tilt forwards and it will fly forwards. But this is quite bad, because Jacob will explain why this is bad for us.
So, with light aircraft, and especially those, the wind and other like breeze and any other wind like factors will blow it more, especially considering the light weight, which would hugely destabilize our plane, which could definitely reduce our chances of liftoff, which is why with a tilt rotor we would have greater success with taking off because the air resistance would be smaller due to the reduced area of the wing perpendicular to the wind.
And also with the tilt wing, the wings, because they're like tilted, they're like pretty big, as you can see. Like in respect of the wind, be going like this, like left to right or something. Say like, and it'll be perpendicular to the wings. So the wings be acting like massive sails, and they'll be blowing us around all over the place. So the wind's coming from like the wrong angle, like a bit diagonal or something. It could hit this side and make us spin around or anything. We don't want that. So that's why this is much better, because these wings are parallel to the direction of the wind. So the wind can only really affect like this small area here, to try and like destabilize, or we had flaps installed, these bits under here, to slow us down. Then the wind can hit them, but that's only really used to slow down the aircraft when coming in for landing. Next is another one of the example of the turbofan, where it kind of sucks air up and moves it around a bit and gets shot around and out the back and go forwards. And then the pure helicopter, that's just like a Chinook, and the compound arc, that's like a regular helicopter. And the folding tilt rotor, we're not actually too sure what that is, because from our like research, we found that sometimes it could be like a house for some reason. And
Should
so
I
we're not too sure
give a
about
picture?
that. You can get a picture up if you want.
I don't even know what I'm looking at still.
So we also decided that we need an airfoil shape. So what shape's our wing going to be? And we found that something from the NASA website, where NASA have done some research, and they found that higher turning equals greater lift. So I think something with higher turning is like on the right, which is more curved, compared to the one on the left, which is more like teardrop shaped or water droplet shaped. So this means that you get a greater lift at slow speed with the one on the right, this one that's curved. And as we believe that our aircraft, when we're going that fast relative to like what the speeds NASA are going at like Mach 10 with their space shuttle re-entries, we thought that we want one that's got a great lift at slow speeds to give us the best chance to allow our tilt rotor to look something similar to this V22 Osprey, to allow it to, when it's the rotors are going, they're up vertically like this, but they'll tilt and they will go forwards, so they'll be parallel to the wings, the actual like engines, but then, or like our electric motors in our case that we're going to use, and the propellers will be perpendicular to the wings. So that should allow us to go chance of that happening and us not dropping out the sky, because that'd be catastrophic if we dropped out of the sky. So we have a picture here of what the folding wing, I can't remember exactly what it's called, folding tilt rotor was called, or I mean, it looks like. And this, it's like a house on the bottom down here, like a pontoon raft type life vessel underneath it, with some like fin things, and then this mess on the top. And we're not actually too sure what that is, or what it's doing, but we are not going to try and build that, because that looks way too complicated for us. There's too many moving parts. Also, we found that because most of this is like this stuff on JSTOR, and over here we found about like on ResearchGate about like gross weight, number of blades. Although we do deal in kilograms usually, it's in pounds here. This is like £124,000. We're trying to build a scale like model type, our radio controlled one, which will be like have a wingspan of like around a meter or a bit less, not like a rotor radius, which is about like 11 meters. Their rotors are 11 times bigger than the full wingspan of the aircraft we're trying to build. So we're not going to be able to have like massive fuel tanks like they do to store loads of all that chemical energy to convert into kinetic energy to make it fly. So we have an idea.
We will probably have to get some sort of a battery. However, with that, the flight time may be limited with some sources right now I'm reading. Saying 30 minutes. However, with other batteries, it's going to be up to 10. However, those are most likely going to be pretty large batteries. So we could slap some sort of a what do you call it? A solar panel on top for some battery power. Or we could also put a small turbine, although that would also reduce efficiency very much.
Yeah, and increase our drag.
Exactly.
But if
So
we put
that
it in
could
the right
be out of the
place,
question. you could also like lift it a bit, if we placed it correctly.
Yeah, we put it in the right place maybe behind the wings or something. The like wake that's coming off, that's like that causes a lot of inefficiencies with the actual aerofoil profile shape, like these. The behind it, like where this writing is, there'll be like vortexes, and all the wind will be not the wind, the air that just come over the wings. That's going like over like this. Will be tumbling and turning around here. If we put like a rotor here, like a wind turbine type thing, it might be able to like make the air flow in a better way whilst generating electricity for us. So that could be another way to improve efficiency, even though it looks like it might decrease efficiency.
I'm actually looking at some drones right now, like model drones of VTOLs. They're a bit different from what we're trying to make. They're close to the quadcopters, which we were looking at earlier. And it says they can carry payloads up to 25 kg. It's actually kind of impressive.
If they're weighing like about a few 100 grams, maybe a couple of kilograms, that could be up
No,
to like
they're pretty big, and it says they have a range of 200 kilometers
200 kilometers. We could,
and
if
up to 10 hours of flight time.
we build a big enough one, we could like we could be nearly lifting us with two of these.
Yeah, exactly.
We could be
Try
flying.
3.
We could be flying to school. Now that'd be an entrance. Just flying in
If
on
we
your.
made 3 each, we could like just like triple the power. We just like flying to school.
If we just get bigger motors, then we can fly to school.
Exactly.
I don't know how. Like we have to check the legal regulations regarding us flying some like radio controlled planes made out of foam and probably maybe a bit of carbon fiber and some other stuff to like around civilians, because that does sound it could be pretty dangerous with us on it. I'm definitely have to wear a helmet.
There's probably going to be also some restrictions on airspace after
Yeah,
a certain size, most likely, because drones, there might be some restrictions, but after probably reaching a scale of 1 meter or more, there's definitely going to be some sort of restrictions.
stay tuned for our next video to figure out whether or not we can actually fly if we could make one big enough to fly ourselves to school. Yes, so currently we decided we're going to build a tilt rotor, but like you can see in where is it, this photo, this is vertical, and because when they are going to have to pivot into forward flight, like you can see in this photo over here on the top right, that's going to change where the mass is of that rotor relative to like the where it used to be. So now the propellers and that have got the torque on the aircraft is like increased because there's a further perpendicular distance from its pivot point, which is the end of the wings. So that means that if we don't balance it properly, the aircraft could nose down and could just hit the ground, and we'd lose probably the front of for half the aircraft, which would not be good. So we will have to make sure we balance it correctly, and maybe there'll have to be some moving mass inside that when the rotors tilt, it moves backwards.
We would probably also need some sort of locking mechanism to keep it at the correct place instead of like just bouncing in between, because that would also, if it's not firmly placed, it would severely damage our plane, especially if one of the rotors just slips down and we're generating lift downwards whilst the other one's up, and we
Yeah,
start doing like donuts around.
they will have to pivot on. They have to be like on the same fixed pivot, and there'll be like one button to pivot both of them at once, not two buttons. Could we press them wrong? Then we could just be like doing donuts, like not not like tail to nose with like across the rings that direction, like barrel rolls, and that would not be good.
Yeah.
All right, so that's it for today. Thanks for watching, and come back next time.